were doing Euclid's geometry. Okay, so everybody learned all the 7 axioms. Let us just quickly revise it. The first axiom is things which are equal to the same thing are equal to one another. Okay, if equals are added to equals, then the whole are equal. Okay, if we add something to two quantities which are already equal, okay, so they will be equal. The whole will also be equal. Okay, and what are the other axiom? Okay, axiom number 3: if equals are
Excuse me,
subtracted.
ma'am.
Yeah, Shazan?
Ma'am, I wasn't there in the previous 9th class of maths.
You were not there in 9th class also.
Yes, ma'am. I actually missed one class. I got some.
Okay, so just
The next axiom is that the things that then after the fifth axiom was things that are double of the same thing are equal to one another, and the fifth is things that are halves of the same thing are equal to one another.
yes, very good. Okay, these are the last two exams, the 6th one and the 7th one. Okay, Shazan, there is nothing much we have studied in the last one. Only the 7 exam we have covered, and depending on the 7 exam, we have completed the question. Okay, just go through the 7 exam and go through the lecture class. You can see the recording and the notes also. Okay, still you find anything tough, you can ask. Okay, you can wait after the class that I usually take, and I will extend 5-10 minutes and I will explain you. Okay, there's nothing much, only 7 exams are there. Very simple, common definition that you can see here. Things which are equal to same thing are equal to one another. Like if A is equal to B and B is equal to C, so it is general, it is understood that A will be equal to C because A is equal to B and B is equal to C. The third thing will be equal to 1. Okay, so and the second axiom is if equals are added to equals, then wholes are equal. Like if I say A is equal to B, so they both are equal. So if I am going to add something that is some same quantity on both the side, that is A plus B, A is equal to B. I'm adding C. So A plus C is equal to C plus what I said. A is equal to, I say A equal to B. Okay. Now, if A is equal to B and I am adding a quantity C on both the sides. Okay. So A plus C will be equal to B plus C also. Okay. In fact, in your mathematics till now, for proving, we always do this. Okay. We add equal quantities on both the sides, or we subtract equal quantities on both the sides, or we multiply any quantity on denominator and numerator. We divide something in numerator and denominator because that is not going to change. That is not going to alter the main expression. Okay. Now the other postulates are axioms are if equals, it's the same thing. If equals are subtracted for equal, then the remainders are equal. Like if I'm saying that 5 is equal, you already know 5 is equal to 5. Okay. Or if I'm saying that x is equal to y and I'm going to subtract z from both sides. So obviously then another quantity will also be same because if x is equal to y and if I'm going to subtract the same quantity on both the sides, so they will still be equal. Okay. Now fourth axiom.
I'm going to show the second axiom. I'm writing them down.
Second one?
Yes, ma'am. Can you show that one? I need to write it down.
Okay, the written one you're saying.
I need to see. Okay, ma'am, got it.
Shazan, till now any doubt what I am telling about axioms?
No, ma'am.
These are common general means you can say statement that you have still now you have been using it. Okay, it's nothing new here. And only 7 and postulate I will cover today. Okay, so Arham, you have written?
Yes, ma'am.
Let's see the other axioms. Okay. Now, axiom number 3, if equals are subtracted. Okay, that also explained. Now, axiom number 4, things which coincide with one another are equal to one another. Okay, things which coincide. Like if I say that that line AB coincide BQ, that means they are falling on each other. Okay, two lines, how can be they coincident? Oh, because they are falling on each other. Like the line A is there and line B, it is totally over it. Okay, पूरी तरह से वो उसको cover कर रही है, उसी के ऊपर fall हो रही है. Okay, then only they are coincides. Okay, in such a way, if AB is coinciding on PQ, that means point A and P are not different. They are the same point. Okay, and B and Q are not different. Okay, they are the same point. Okay, so actually the both lines are same. Okay, so they are equal. The whole is greater than the part. Obviously, this is a general statement. Obviously, if I am having a full glass of water and if I'm taking, in fact, if you take a spoon of water from it also, then also comparing from the full glass, that is always going to be lesser. Okay, or not? Yes or no? If I'm having 10, okay, and I'm taking 1/10 part, and I am taking out 1/10 from 10 part from any object. So the original will always be greater or not. Okay, so this statement is saying the whole is greater than part. Okay, things which are double of the same thing are equal to one another. Okay, for example, if your A is equal to 2x or 2y's, double of something, okay, and your B is also double of the same thing. Like A is equal to 2x and B is also equal to 2x. That means they both are equal. So A is equal to B because they are double of the same thing. Okay. Now, seventh, things which are half of same thing are equal to one another. The same statement is there, only instead of double, we are using half here. So if A is equal to x by 2 and B is equal to x by 2, so A is equal to B. Okay. Any doubt in all the 7 axioms? Anybody?
No, ma'am, I'm still writing the 6th one down.
Okay. In fact, we did some of the questions also on this. Only you have to use the axioms. Okay. Now, today we are going to cover the 5 postulates given by the Euclids. Okay. Written around?
I'm just almost finishing. I'm almost done.
You can go through the H1 notes also in your student location or in your Alamco app. Okay. There also I have uploaded this.
I'm done.
Okay, now let's see the postulates. Now, what are the postulates? As I discussed in the starting, so what are postulate? Anybody remember what do we mean by postulate?
Ma'am, it's like rules of like geometry.
Yeah, the term postulate was used for assumption specific to geometry. Okay, those assumptions that we consider only for the geometry, whereas axioms are used throughout your mathematics, for arithmetics, also for algebra, also for geometry, also. So axiom is all used overall mathematics, but postulate are specific to geometrical purposes only. Okay, like for lines, for angles, for rays, like this. Okay, so let's see the first postulate of Euclid's. So what does the first postulate say? A straight line may be drawn from any one point to any other point. Okay, so when you are drawing a straight line, actually a straight line is between 2 lines. Okay, so according to first postulate of Euclid, it says that only single. Yeah, hello, Vika.
Yes, ma'am. I have a question for like ma'am, for the first postulate. Ma'am, it says that ma'am, a straight line can be drawn from any one point to any other point. Ma'am, but it also says that a line can be like extended in all directions. Like a line does not end anywhere. It gets extended indefinitely on both sides. So how can we say that it ends at 2 points?
It's saying that a line can be drawn through.
It is not saying that it ends at 2 points. It is saying that the first postulate is saying that between 2 points you'll have a single line. Okay, that so many.
Can we say line segment?
Yeah, what it's trying to say is like those 2 points, the line will be in between those 2 points, not ends of those 2 points.
You mean like collinear points, basically, like it passes through them. Ma'am, is that
Yeah,
what you're saying?
points, it's not 2 points. Okay, Advika, just make sure that when you are talking about collinear point, the minimum point should be 3.
Ma'am, three, yes, ma'am.
Yeah,
Okay,
because
ma'am.
between
Yes, ma'am.
2 points, you always get a straight line only. Okay, whenever you are going to join 2 points, you always get a straight line only. But if there are 3 points, then you can get a pattern. Again, 2 points are in a straight line and anywhere else. So collinear point means minimum 3 points. Okay?
Yes, ma'am.
Now let's see. A straight line may be drawn from any one point to any other point. So okay, so straight line is from any one point to another point. You can draw a single straight line. That means it. Okay, there will not be so many points. Okay, so between 2 points you cannot have indefinite many straight lines or 1 or 2 straight lines. Only a single straight line can only be there. Okay, postulate 1 state this. Okay, let's see the statement here. It means that at least one straight line passes through 2 distinct points, but it does not say that there can be more than one such line. Okay, so there will be always a single line between 2 points. Okay, not indefinitely many points or 2 lines. In fact, not 2 lines also. Okay, so Euclid has frequently assumed that there is a unique line joining 2 distinct points. This result can be stated in the form of an axiom. Okay, now how can the statement taken as an axiom? Given 2 distinct points, there is a unique line that passes through them. Okay, so between 2 points, a unique line. You can see a diagram here on this side. Between P and Q, we have so many lines from the point P, okay, and we have so many lines from the point Q, but we have only single line that is between the point P and Q. Okay, between the point P and Q. If you're going to
There's
take
an infinite amount of lines from one point, but if you take 2 points, there's only 1 line.
yeah, from 1 point you can draw infinitely many lines. Okay, because it is. But if you're taking 2 points and you want that from 2 points, then there is only single line that pass between the 2 points. Okay, now. Postulate number 2. What does the postulate number 2 say? A terminated line is line segment. Okay. Now a terminated line is stated as a line segment. Previously, Euclid, when Euclid was deriving this postulate, he used to say that terminated line. So a terminated line can be produced indefinitely. Okay. The Euclid's terminated line is now called a line segment. In other words, we can see that a line segment can be extended on either side to form a line. Okay. So when there is a line segment, so you can draw it. You can a terminated line can be extended on any of the side. Okay, from side A also and from side B also. Okay, according to your according to your question or your proving, you can extend it. Okay, postulate 3. It is just a simple statement. You can say a circle can be drawn with any center and any radius. Okay, if depending on the radius, the size of the circle will depend. Okay, so from any point you can have a, like if you want to draw a circle. Okay, so from any point you can take an for any radius, you can draw a circle. Okay, if you will take the bigger arc, bigger radius, bigger circle will be drawn. Okay, if you're going to take smaller, it will be a smaller circle. Okay, but you can draw a circle with from any point and any radius.
I need to also write the axioms.
Yeah,
Postulates. I'm writing them.
okay, that's very good. In fact, you have to learn these postulates because they can be directly asked in 1 or 2 marks. This chapter is not going to cover a very great weightage. Okay, only the question you will get in 1 marks, 2 marks, that's it. Okay, 3 marks maximum. I cannot get 6 marks question from here. Now, postulate number 4. Okay.
I need to write postulate number 2.
You have not written postulate number 2?
I'm writing it right now.
Well, you can write the first line only. A terminated line can be produced infinitely, or you can say that from here, that a line segment can be extended on either side to form a line. Okay, given line segment.
I got the snapshot. I can see it from there.
Okay. Okay. Now postulate number 4. Now what does it say? That all right angles are equal to one another. Obviously, it's a general statement. All right angles. If you are drawing a right angle, whether it is a bigger figure or whatever, but right angle means what? It is 90 degree. Right angles mean 90 degree or not? Okay. But different figure also, if it is saying that there is a right angle, then it will be equal to one another, because right angle means 90 degree and all 90 degree will be equal to one another. Okay. So in the figure A, if you see the first one, it is ABC, and in the second PQR, in the third XYZ. All are having a right angle. Okay. So right angle means what? Right angle is equal to 90 degree, 90 degree. Okay. So that means all the 3 angles will be equal to one another because it is 90 degree. Okay. And this is the symbol we use for 90 degree. Okay. Any doubt in these 4 postulates? Okay, so there comes the 5th postulate. Okay, and there are many different versions of this 5th postulate also. Okay, so we'll see later. Now, what does this 5th postulate say? First, we will understand the statement. Okay, and then we'll understand what this statement is trying to say. Okay, if a straight line, okay, a single straight line is falling on 2 straight lines. Now, it is not telling that the 2 straight lines are parallel or whatever. Just simply 2 straight lines. So it may be that they are not parallel. Okay, because parallel lines will never touch each other. They will always be, they will never going to intersect. Okay, so it is just talking about 2 straight lines. Okay, so 2 straight lines make the interior angle on the same side. Okay, now if we have drawn this line, okay, and one straight line, all are straight line. Straight line means between 2 points. Okay, you can get a straight line. Okay, now I have drawn a line. Okay, that is intersecting the 2 straight lines. Okay, now okay, if you see an angle, okay, on the interior side, okay, interior side, if you see the angle and the sum of the angle, okay, is less than 2 right angles. 2 right angles means 90 degree plus 90 degree, that is 180 degree. Okay, if you will assume it is as angle 1, so angle 2, so angle 1 plus angle 2, angle 1 plus angle 2. If the sum of is less than 180 degrees, see the statement here. If a straight line falling on 2 straight lines makes the interior angles on the same side of it taken together less than 2 right angles. Okay, if both the angles on the interior side, if you are taking it together, the sum of it, and it is less than the 2 right angles, that means less than 180 degrees, then the 2 straight lines, if produced indefinitely, meet on that side on which the sum of angles is less than 2 right angles. Okay, so see, okay, when this is
the 3rd and 4th postulate, I need to take a screenshot.
You want 3rd and 4th postulate?
Yes, one.
Okay, just let me explain this, and I am giving a screenshot. Okay, just a minute. Okay, see, if this is line L, this is line M and this is line N. Okay, so M and N, on M and N line, if a line L is falling, so interior angles if you will take, so there are 4 interior angles. Okay, and we have to take on one side only. Okay, you can take it at angle 3 and this is angle 4. Okay, on one side of, okay, on one side, so we can take 3 and 4 also. Okay, because that is on one side. But if you take 3 and 4, you can see the angles are obtuse angle type. Okay, so if angle 3 and angle 4, if you sum angle 3 and angle 4 and it is greater than 180 degree, then the two lines, the line M and N, are not going to meet on that side. Okay, they will be moving far and far and far.
Oh, I got it. It's like if the lines are not, if they are not equal, or if they're not equal, or if they're not equal or greater than, if they're not, then it will merge at some point. But if they are equal or more than 180 degrees, they will never touch.
Yeah, so this time if the sum is greater than 1, it is not going to meet on that side. It is going to always move far from it. Okay, and if you see
N1 and N2, since that if you add them up, they will be less than 180 degrees, so they will meet.
yeah, so that is what I'm saying. If you are going to add angle 1 and angle 2, okay, and if the sum is less than 180 degree, that means if you are going to extend these lines, they are going to meet somewhere. It is not defined that where it is going to meet, but it is definite that it is going to meet at some point. Okay, there will be a point of intersection if the sum is less than 180 degree. Okay, and in parallel lines, it is always going to be 180 degree, exact 180 degree. Okay, so it is not going to meet. Yeah,
The third and fourth postulate.
yeah, third and fourth postulate. Okay, this is your third and fourth postulate. So third postulate is what? That a circle can be drawn with any center and any radius. Okay, you can draw any circle with from any point and any radius. Okay, and depend on the size. Okay, if the radius is smaller, the circle will be smaller. If the radius is bigger, the circle will be bigger. Okay, and postulate number 4.
I got the screenshot.
Okay, all the right angles are equal to one another, because right angle means what? 90 degrees. So all 90 degrees will be equal to one another. Now, if it's this fifth postulate, what does it say? After, so the line AB and CD will eventually intersect on the left. Okay, obviously I explain. Okay, on which side of the line the angle, the sum of the interior angles is less than 180 degree. On that side, the two lines are going to intersect. Okay, postulate 1 to 4 are simple, and these are taken as self-evident truth. Okay, so these are, doesn't need any derivation for it. Okay, they're self-evident truth. Okay, using this postulate exam. Okay, so Euclid, using these postulates, he derived many more theorems, many more prepositions. Okay, and all. Okay, now let's see a question here. Okay, okay. First let us see the question and then we will see. Okay, now what does this question say? Equal, square are equal. Now a square is a polygon made up of 4 line segments. Okay, now it is not defining you square. We already know that square are 4-sided figure, 4-sided polygon whose all the 4-sided are equal. Okay, but here it is just telling you a definition and you have to prove it. Okay, so a square is a polygon made up of 4 line segments, out of which length of 3 line segment are equal to the length of 4. Okay, so all the 3 from 4 line segment, the 3 line segment, any 3 line segment, okay, that are all equal to 1 line segment. Okay, length of 4, and all its angle are right angle. Okay, all its angle are right angle. So using Euclid's axiom postulate to justify that all angles and side of a square are equal. So you have to prove that the square has all the 4 sides equal and the angles are also
But why is it an axiom? Ma'am, isn't it very obvious that all sides in a square are all angles of a square are obviously equal?
Yeah, actually, but generally, when something you see or whatever you are studying, there was some point that nothing was known. Okay, we have derived everything. Whatever you see, in fact, every day all the mathematician or the scientists, those who are working, they're deriving new concepts, new things. Previously, when Euclid things, nothing was there. We derived it. Okay, and from using all those axiom postulates, we derive many more new things. So, according to this statement, simply this thing, taking this question, that you don't know anything like a square. Okay, so now you have to prove that square is a polygon which has 4 sides and all its 4 sides are equal and all angles are 90 degrees. Okay, do you think that Advika, that when there was nothing from early age, then there was mathematics? Everything was right. Everything was, you can say, scripted. They have been written. In fact, today also many new theories, many new, you can say, they are still, we are, okay. So now,
Yes, sir.
to the question, we are having a 4 sides polygon. Okay, you can name it as B. Okay, we have already, because these are already derived, so we know all the you can say all the properties of this figure. That if a polygon is three-sided, so we call it triangle. There are three types of triangles. What are the different properties of three types? Then if we are four-sided and all the four-sided is 90 degree, then it is a square. And it, so there is a like okay.
Ma'am, could you show the fifth postulate?
Go ahead, huh?
Can you show the fifth postulate?
Yeah. So the fifth postulate is going to be here. Okay. A straight line falling on two straight lines. Okay. Makes the interior angles on the straight side taken together less than two right angles. Then the two straight line, if produced indefinitely, meet on that side on which the sum of the angles is less than the
Two right angles.
Yeah.
I take a screenshot and I'm just doing it.
Now the figure. Now it is saying that the three of the line segment is equal to one of the line segment. You can choose any one of the line segment. Okay. So I am choosing AB. So AB, the line segment which is equal to all the three line segment. So that means that AB is equal to and BC is equal to AB and BC is equal to AB. Okay. So from axiom 1, see, from axiom 1, see, AD is equal to AB, BC is equal to AB, and BC is also equal to AB. So all are equal to the same quantity, same thing. Okay. So from axiom 1, you can see that AD is equal to AB, C equal to BC. So all the four sides are equal. So all four sides are equal. Okay. Now it is saying that all the angles are 90 degree. Okay. So angle A is equal to 90 degree. Angle B is equal to 90 degree. Angle C is equal to 90 degree. And angle D is equal to 90. Okay. And from postulate, which postulate? From postulate number 4, we know that angle B are equal to 1. That means angle A is equal to angle B, equal to angle C is equal to angle D. Okay, so all the angles are equal to one another. Square as
तो मैम से बार हमको करवाती हैं मैम बोलते हैं
Advika, you saying something? This is square, all sides are equal and angles are 90 degree. Okay, any doubt in this question?
Ma'am, so if we're writing the answer, can we just directly write like using axiom this? We can say that this is equal to this, this is equal to this. Hence, this is why, and just conclude it with hence instead of doing this whole, ma'am, including the postulate and all. Can we just write one axiom and finish it?
Just one axiom means I don't understand your question. Okay, Advika. Like first one I have used like AD is equal to AB is equal to BC.
Yes, ma'am.
So this I have used as axiom 1 by using axiom 1. Okay?
Axiom 1, yes, ma'am.
Yeah. And
Ma'am, so ma'am, but we have to prove that angle A is equal to angle B is equal to angle C is equal to angle D, right?
no, prove, see, from question if you see here, it is written that the length of the floor and all its angles are right angle. Okay, it is given that all its angles are right angle. So it is already given to you that angle A is equal to 90 degree. Angle
yes,
B
ma'am, but it's saying that using Euclid's postulates, or ma'am, using this piece of information, we have to, like, using the information that all sides are equal and all angles are 90 degrees, we have to prove that the sides are equal, ma'am. But isn't that already a postulate that says that all angles of a square?
So in fact, your proof means that you have to use a perfect postulate or a perfect axiom to use it. Okay, because see, in geometry, what happens? All the things we are not going to prove. How we prove? We use many things we prove also, and many things there are already a theorem is already there. Okay, we use from theorem number this, or from theorem number that, or from this theorem, or from we already know that the opposite angles are equal. The sum of a triangle is 180 degree. Okay, so many things are already defined. So we need not to define it again, or we need not to prove all the things again. Okay, so we can just directly use those axiom, those postulates, those theorems in our when we are doing proving, and we can directly use it. Okay, so like here I have written that AB is equal to AB is equal to AB is equal to BC is equal to BC. So it is directly from axiom 1. We already know from directly from axiom 1 that when the things are equal to the same thing, then they are equal to each other. Okay, so from this axiom we are using it. Okay, in the bracket, you can write here since. This is equal to this. You can write here since. You can write the first axiom. Okay, Advika? And then all the angles are already given that it is 90 degree. So from postulate number 4, okay. So if you see postulate number 4, it is already written here that all right angles are equal to one another. So you're just going to write that from postulate, since from postulate 4 or since postulate 4, all angles are equal, all right angles are equal to one another. Therefore, angle A is equal to angle B is equal to angle C is equal to angle D is equal to 90 degree, because all are 90 degree and all 90 degree will be equal to one another. Okay, understood, Advika? Now still any doubt is there?
No, ma'am, I got it.
Okay, in geometry, maximum time we use the theorems that are already given to us. Okay, in triangle, we always say that the sum of the triangle is 180 degree. Okay, or when we see a straight line, okay, a straight line, okay, it is of 180 degree. Okay, so these things have already been derived. Okay, so we need not to do it. Okay, we can just directly write the statement, directly write the theorem, and whatever that theorem tells us, we are just directly going to include that. Okay, if a theorem says that the sum of the triangle is 180 degree, okay, we are not going to prove it. We are just going to use it that this angle is this angle is this, then this angle will be equal to this. Okay, because of this. Okay, so we were here. Now you can see a theorem is here. What this theorem say? Two distinct lines cannot have more than one point in common. Okay, if there are two separate different lines, then they will not have have more than one point in common. Okay. 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 So if there are two lines, okay. So if two lines are there, so they will only have a single common point. Okay. Okay. If they are not parallel. Okay. So you are going to have only one point of intersection. Let's see how we are going to prove this. Okay. Now here, Advika, like you asked me, so here it is a proof. Okay. Now, whenever we are solving any complex problem or any problem where we can use this theorem, so we are just directly use it. Okay, otherwise that question is going to extend over and over. Okay, a simple question can extend. Okay, because in single question also you will be using many theorems and many axioms, many postulates. Okay, now let's see this theorem. Now how can we prove this? We are going to prove this via contradictory method. What is contradictory? Like it is saying that two distinct lines L and M are going to have a single common point. So we will assume it that it is not having a single point. We are having 2 points.
Could you show the sixth postulate?
No, only fifth postulate. Only 5 postulates we are covering. There is no 6 postulate. Only 5 postulates. See, this was a question and only 5 postulate. Okay, and this is a theorem that I'm just now telling you. Okay, that two distinct lines cannot have more than one point in common. Okay, if there are two different lines are there, so they'll not have more than one common point. Okay, one or no point. Okay, if the lines are parallel, no point will be common, and otherwise it will be having only one common point. Okay, now let's see. So what we have to prove that L and M, the line L and line M have only one common point. So by contradictory, what we will do, we will assume that the two lines L and M intersect at two distinct points. Okay, so we are assuming that there are two points where the lines are intersecting, the point P and point Q. Okay, then L contains both the point. Obviously, if they are intersecting at 2 points, that means that both the points are common in both the lines. Okay, both the lines are containing that that point. Okay, so line L will also have P and Q, and line M will also have P and Q. Now, when there is only one single line between 2 points. Okay, but from the axiom we know that only one line can pass through two distinct points. Okay, between two distinct points we can have only single line. That means it again contradicts what we has assumed. Okay, that P and Q we are having 2 points. Okay, so that means L will be equal to M. Okay, according to what we have assumed, L will be equal to M. Okay, because between 2 points there will be only single line. Okay, and P and Q both lies on L also and M also. That means L will be equal to M. Okay, so our assumption is wrong, and therefore two distinct lines cannot have more than one point in common. Okay, so we'll be having only single point common. Okay, any doubt? So this is your theorem. Okay, you have to remember this is your proof. Okay, as you are starting, so proof the theorem can be directly asked. Okay, but afterwards you just have to use the theorem, and this theorem will be used for proving other questions. Okay, or okay, like when Euclid proved these postulates and axioms, he used this postulate and axiom to prove many other new theorems and postulates. Okay, and from them he used many more. He proved many more also. Okay, so this you have to remember, this is a theorem and this will be used when you are proving something. Okay, so two distinct lines cannot have more than one point in common. Remember this. Okay, so if there are two distinct lines and if you are extending it, So it will have only one common point, okay, like this two lines, okay, not more than 2 points. Because if you are having 2 points, that means both the points between between 2 points, we can have a single line. So that will be a same line. That means L and M are the same line. They are coinciding, okay. Now, some of the common basic definition that we'll be using in geometry, and since I'm going to start the next chapter as line and angle, so these definition will be used, okay. So let's see, what do these terms mean? Line segment. What do we mean by line segment? A part of a line which is bounded by two distinct points is called the line segment. It has two end points, okay. So line segment, okay. And line segment, how do we represent? Like AB, and this is a line segment, okay. So it's a simply line and it has two endpoints, okay, A and B, okay. So this is a line segment. Now, interior point of a line segment. Interior point of a line segment means, like if you see, this is A and B is a line segment. So there will be, so when you draw a line, so there are so many points. After joining all these points, you actually make a line, okay. So the line, the point that a line between this A and B, you'll have to exclude A and B. A and B को include नहीं करना है, and remaining point that is inside these points, okay. This point को exclude करके, all the points that are lying between this, drawing it, okay. They are, all these points are what? They are interior point of a line segment, okay. A point P is called an interior point of a line segment AB if P lies between A and B, but P is neither A nor B, okay. Between A and B, okay. The line segment, the end points, between those end points, उस end point के बीच में जितने भी points line करेंगे, that all points are your interior points of a line segment, okay. Now, congruency of a line segment. Congruency means what? If we are, in fact, whenever we say congruency means both the figures. When we are talking about two figures that they are congruent, that means both the figures are same or similar, in fact, similar, okay. So two line segment, AB and CD are congruent, okay. How can we say that the two lines AB and CD are congruent? If the trace copy of one can be superimposed on the other so as to cover, okay. For example, okay, just I'm drawing two figures, okay, A and B, okay. Now there's another one, that is P and Q, okay. If these lines can overlap each other, okay. If you're trying to put line A on line B, so they are exactly overlapping. That means point A is on point B on P and point B is on Q. That means they are congruent lines, okay. Understood? Any doubt? Congruency of line segment and congruency. This congruency word is denoted by this. Wherever for your triangles, if you use congruency or whichever, congruency will be represented by this symbol. Okay, there will be a 2 equal to sign and the two figures are similar to each other. Okay, so this is the symbol of congruency. Okay, now ray. What do you mean by ray? How can you represent ray? When you are representing ray, so that means AB is a ray. See, you can see a bar over it. If you're seeing a bar over the line, that means it is talking about line segment. Okay. In geometry, you will see these symbols. Okay. Be very much clear that if you see a bar over the alphabet, that means it is talking about the line segment. If you see and if you see an arrow, that means it is a ray.
And that's ray. The ray goes from A to B and then B to infinite.
Yeah, and if I am marking the ray from A to B, that means the ray will be on the B side. Okay, the line will be on the B side. If I write ray like this, so it will be.
I mean, it will still be a ray, but instead it will go from B and then to A and then it goes in there.
Yes. Okay, it will be a ray only, but it depends on which side the arrow is pointing. On that side only, your line will also be pointing. Okay, that side only you extend the line. Okay, so what is the ray?
Ma'am, it has arrow on two sides, then it's a line, right?
It is a it's a line. In fact, opposite rays. You can you can see this figure also. So it can be extended on both sides. Okay, this ray can be extended on both sides. Here you are having ray B to A. That means it will be extended to B side. Okay, but A B on both sides, so it will be extended on also left side also.
Then this is a line.
No, it is still a ray, but you are having
it's going.
It can be extended on both the side. Okay. Like A and B, okay. Whenever you draw, you can say you have marked a number line, okay. On number line, you always have arrows on both the sides. Yes, because on both the side you are going to extend. One side is infinity, positive infinity. One side is negative. You never mark it a straight line. Why? Because you need to extend that line. Okay, it goes infinity. That's why we put arrow on both the side. And if arrow is only on the one side, that means the line will only be extended on that side. okay, not from the other side. Okay, if arrow is towards A, so line can be extended from A, okay, on the A side. If the arrow is on the B side, that means the line can be extended on the B side. Okay, ray is also a line only, but it is a ray, that means it will be extended on one side. And if you are having rays on both the side, that means the line can be extended from both the side. Okay, so ray, a line segment AB, so it is also a line segment only. Okay, I've said a line segment AB when extended infinitely in one direction is called the ray, and it is denoted by AB. Up in the upside you will mark an arrow, and from which direction, on which side it will be extended, on that alphabet you are going to mark it. Okay, if you are marking a line as PQ, okay, and your